Enterprise, Houston.
Go ahead, Demo.
We have a couple of updates to your pre-flight cue card, the altitudes.
Okay, stand by one. Okay, we're ready to copy.
Separation is at 23.0. Next one, 18.0. Rolled out on final at 8.3, and then 1.9er. I'd suggest you go ahead and start your engines and begin your taxi.
It's called Enterprise, first of the Space Shuttle orbiters, the beginning of a new space transportation system. A craft that can carry up to 65,000 pounds into space and land back on Earth like an airplane. 5 times, 2 astronauts were carried piggyback atop this 747 jet and released. 5 times, they brought the huge spaceship in for powerless landings.
Okay, the gear is coming down at 270. Gear coming. Doors open and they're all down, coming down. Look down here. 50 feet. 40 feet. 30. 20. 15. 10. Holding 10. 220 about 5 feet.
Summing up the year's work for all 4 of the astronaut crewmen, astronaut Gordon Fullerton.
We're at the end of the approach and landing test phase of this program, but it's really not an end, it's a beginning. It's just a small step really accomplished toward getting the orbiter into space, and then in that aspect I'm looking forward to more of the same exciting times as we continue on toward that first orbital flight.
Enterprise will not be the first shuttle into space, but this one will be. Shown here being assembled by Rockwell International, it is simply designated Orbiter 102.
102 is undergoing construction right now in Palmdale, and it's scheduled to be shipped the middle of next year over to DFRC, where we'll perform a hot fire test on it. We will mate it to the 747 and fly it to Florida in preparation for launch into orbit in March of 1979. After about 24 hours in orbit on 102, it also will land here at DFRC on the lake bed in the manner similar to the test flights that we've just completed on the approach and landing test.
Also completed this year, the 154-foot-long, 27.5-foot wide external fuel tank for the shuttle. Designed and assembled by Martin Marietta at NASA's Michoud Assembly Facility near New Orleans, the external tank will fuel shuttle's 3 main engines on the way to orbit. Another major milestone for the new space transportation system was the successful test firing of one of the 2 Thiokol solid rocket motors that will also help boost the shuttle orbiter into space. This animation shows how they work during launch. The 2 solid rocket boosters strapped to each side carry their own propellants and burn for about 2 minutes before separating. Their onboard parachutes will then bring them back to Earth for recovery and reuse. The large external fuel tank continues feeding the shuttle engines for an additional 6 minutes, separating just before the shuttle reaches orbit. This is the only part of the shuttle system that will not be used again. When NASA announced it was recruiting between 30 and 40 new astronauts, more than 8,000 hopeful candidates responded, including over 1,500 women. The Johnson Space Center in Houston is in the final screening process to select from this group both mission specialists and pilots for future space shuttle flights. To get a feel for handling large structures in space, engineers at the Marshall Space Flight Center have been practicing underwater, the closest you can come for long periods of time to simulating the weightlessness of space. It's anticipated that the shuttle will make the building of large space structures possible, as well as the assembly of heavier satellites and instruments to better observe Earth and provide improved communications. Even solar satellites could be constructed to beam the sun's energy to Earth if it becomes an economic and reasonable alternative to some of our ground-based energy resources. Many of the early shuttle flights are already booked with confirmed payloads, according to NASA's Director of Pricing, Launch Agreements, and Customer Engineering Services, Mike Smith. This payload section of a shuttle under construction gives some idea of the space available.
On Earth. Well, we're sold out on flights through 1980 and have firm flight assignments through 1981. Typical of these flights are the launch of a long-duration exposure facility for NASA on Flight 7 and its retrieval on Flight 17. We have a full manned space lab line on Flight 11 and a Jupiter orbiter probe flying on Flight 26. We have numerous communication satellites being launched for Telesat Canada, ComSat, Satellite Business Systems Corporation, and India in the early 80 and 81 time period.
Manufacture of the first flight unit has begun on Space Lab, shown here in mock-up. Space Lab is unique because it represents a cooperative venture by NASA and the European Space Agency. To be built in self-contained modules, the Space Lab will be placed inside the shuttle payload section. There, from 1 to 4 payload specialists will attend to a variety of experiments while working in a shirt-sleeve environment. Space Lab is expected to make significant contributions to science, medicine, industrial processing, and other fields. In space science, 2 unmanned Voyager spacecraft like this are now on their way toward the planets Jupiter and Saturn. Their journey could last over a decade, with investigations of more than a dozen major planetary bodies, including Uranus. The program is designed to yield valuable new information about the origins of the solar system and formation of the Earth. One of the ways it will do this is with pictures. Dr. Bradford A. Smith is Associate Professor of Planetary Sciences at the University of Arizona and team leader of the imaging experiment on Voyager.
We begin our observations of both Jupiter and Saturn approximately 100 days before we arrive at the planets themselves. During that period of time, we're constantly looking at the planet. Each planet, both Jupiter and Saturn, rotates in approximately 10 hours. So every 10 hours, as we're approaching these planets, over that 100-day period, we will see the whole surface of the planet rotating beneath us. As we get closer and closer, the resolution gets higher. We see smaller and smaller features. And as we get very close, we finally get so close that we can't see. We don't have enough pictures to cover the entire surface of the planet. But we will select out particular features of great interest observed during that so-called observatory phase, and these features will be targeted for close examination as we fly by.
The Voyagers will eventually leave the solar system, each carrying a cosmic greeting card in the form of a copper record. Called the Sounds of Earth, they were assembled by a group of prominent scientists and educators. The record begins with 115 photographs and diagrams in analog form that describe mathematics, chemistry, geology, and biology of Earth and our location. The pictures are followed by spoken greetings in 60 languages.
Shalom. Hola y saludos a todos. Selamat malam hadirin sekalian.
Hello from the children of planet Earth.
The sounds of weather, surf, birds, and other animals, and almost 90 minutes of music from around the world. Finally, here in part, is the text of a printed message from the President of the United States on the chance that someone is out there. This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so we may live into yours. We hope someday, having solved the problems we face, to join a community of galactic civilizations. This record represents our hope and our determination and our goodwill in a vast and awesome universe. How stars produce the energy that makes them burn so bright, and then how they transmit this energy through millions of miles of space, losing very little intensity along the way, is of great interest to scientists. To study the stars, HEO-1, High Energy Astronomy Observatory, was launched in August. Already, HEO's instruments have found a gigantic star whose X-ray radiation increases violently over a period of time, then returns to normal. HEO-1 will be joined in its task of mapping the sky for X-ray sources by 2 other observatories in the future. NASA continued applying the technology and science learned in space to improve systems for managing the Earth and managing our business here on the ground. This includes further use of our remote sensing capabilities, which enable us to look at the whole Earth or large regions of the Earth in ways not previously possible. Landsat satellites 1 and 2, for instance, are helping us understand the condition of agricultural crops, forests, and groundwater, observations that make it possible to predict and manage more efficiently. Most of NASA's launches this year were paid for by other users in other countries. These included launches for the European Space Agency, Japan, Indonesia, and Italy. Not all the launches were successful, however. Both a Delta and an Atlas rocket failed shortly after liftoff, the first unsuccessful launch in 3 years for the Delta and since 1975 for the Atlas. More and more, NASA is working with other government agencies, such as the Department of Energy. NASA's understanding of rotating machinery, solar cells, and heat transfer is being applied to the development of windmills and better turbines. The Lewis Research Center in Cleveland, for example, is gathering information on as many electric vehicles as possible and is also working to improve nickel-zinc batteries. NASA is also applying solar energy technology to new developments that may bring it into effective use as part of the National Energy Program. Efforts to apply technology to make aviation safer, more economical, cleaner, and quieter continued this year at several NASA field centers. Energy efficiency to curb airplane fuel consumption has high priority. Areas of study include engine research, improved shapes, computerized flight control systems, and lighter, stronger aircraft structures. These crash tests at the Langley Research Center are an attempt to find out what happens when a general aviation airplane does just that. The highly instrumented plane and dummies should help aircraft manufacturers build even safer airplanes in the future. These spin tests look at a different safety problem, the problem of spins and stalls in general aviation airplanes. In part of the project, researchers are trying to determine the effects of tail design on spin characteristics. A new research aircraft, which combines features of both helicopters and conventional airplanes, the XV-15 tiltrotor, completed its first phase of flight testing. These short and vertical takeoff and landing aircraft may one day improve intra-city transportation. (1977), an important year for both aeronautics and space research, with much of the technology finding down-to-earth uses.